Have you ever thought about what the universe looked like right after the Big Bang? Just imagine a colossal explosion that gave birth to all matter and energy in existence. Scientists have long pondered this very question using a myriad of techniques to unlock the secrets of the universe's infancy. The Big Bang theory posits that the universe began as a hot, dense point nearly 14 billion years ago. As it expanded, it cooled and evolved into the vast cosmic expanse we know today. But how do we know this? Where's the evidence? Enter the cosmic microwave background, or CMB for short. This is essentially the afterglow of the Big Bang, a form of light that permeates the universe, whispering tales of its early stages. It's like a cosmic baby photo, capturing the universe just a few 100,000 years after its birth. Now you might be thinking, how can we possibly see this ancient light? It's not something you can see with the naked eye, but scientists have developed ingenious ways to detect it. This we're talking about is the cosmic microwave background, or CMB, a relic of the early universe that's just out of sight, but not out of reach. So, how do scientists detect this elusive CMB? The answer lies in satellite technology. Picture a highly sensitive microwave receiver like a cosmic radio, tuned to detect the faint ancient echoes of the Big Bang. Satellites equipped with these receivers are launched into space far from the noise and light pollution of Earth to listen in on the universe's oldest broadcast. And when we say oldest, we mean it. The CMB is the oldest light in the universe that we can detect, dating back to a time just 380,000 years after the Big Bang. To put that in perspective, if the entire history of the universe was a year, the CMB would be from the first second of January 1st. It's a snapshot from the universe's infancy, a time when it was still a hot, dense soup of particles before stars or galaxies had even begun to form. But the CMB isn't just old, it's informative. By studying the tiny fluctuations in temperature and density within this ancient light, scientists can glean valuable insights about the universe's age, composition, and development. The CMB tells us that the universe is roughly 13.8 billion years old, and it provides evidence for the existence of dark matter and dark energy, two of the biggest mysteries in cosmology. The CMB also gives us a window into the universe's past expansion and possible future. It's like reading the rings of a cosmic tree. Each ripple in the microwave background tells a story about a different era in the universe's history. So the CMB is like a baby picture of the universe, offering a glimpse into its earliest days, a picture that's worth more than 1,000 words. It's worth 13.8 billion years of cosmic history. And that's a story worth tuning in for. So, to sum up, what's the big deal about the cosmic microwave background? Well, for starters, the cosmic microwave background, or CMB for short, is the oldest light we can detect in the universe. It's like a snapshot taken just a few 100,000 years after the Big Bang, offering us an unprecedented look at our universe in its infancy. This ancient light, often referred to as the afterglow of the Big Bang, has been traveling through space for over 13 billion years before finally reaching our telescopes. By studying this primordial radiation, scientists can glean crucial information about the early stages of our universe, its composition, and how it has evolved over time. In essence, the CMB serves as a cosmic time machine, allowing us to investigate the most fundamental mysteries of the cosmos. And that, my friends, is the big deal about the cosmic microwave background. Next time you gaze at the night sky, remember that there's a lot more going on than meets the eye. Thanks to the cosmic microwave background, we're able to peek into the universe's past.